Question 13, we have a circle with a bunch of straight lines making angles all over the shop. So this is a classic circle theorems question straight away. Which circle theorems are involved? Of course, we'll dig a little deeper for that. So we have been given the angle 79 degrees here between our tangent and this BD chord. We have been given 41 degrees in between this tangent and DC, and of course we have other shapes involved in this question. We have an isosceles triangle coming from the center O. We have another line here given by BE, and the question is asking us write down the size of angle BED. So B to E to D means that we are interested in this angle here. So, based on this question, there are a few circle theorems that are at play here. The first one that springs to mind is actually one of the trickier ones, the alternate segment theorem. So we have our tangent like so. The angle between a tangent and a chord is equal to the angle in the alternate segment. So that is the angle that's created using these two ends of the chord that is drawn in the other segment here, means that these two angles here and here are equal. So although I drew it in green, technically that angle is blue. So I can quote straight away that our angle BED is 79 degrees. Part B, work out the size of angle BOE. So BOE is this angle in here. So I'm looking for that. We know that the blue angles are 79. We know that the red angle is 41. Let's look for what other circle theorems could be involved here. So we have a radius that meets our tangent at point B. So we have right angles on the right. We have right angles on the left. This may or may not be relevant. I'm just pulling at the thread here. We have this angle in there that's going to be 90 minus the 79 in blue, giving us an 11 degrees. So this may or may not be relevant later, but I'm just drawing it now. We have, what else do we have? We have the fact that our angle that is on this chord, the opposite angle to that 79 across here, will be the 90 plus that 11, or I could just say it's going to be 180 minus 79, which will give us 101. So that angle there is 101. That's not actually, I don't see how that's going to help us. No, now I see it. So we have 101 for this angle here, and we have 41 for this angle here. So if I'm trying to find the third angle up top of this triangle that I'm marking here, that'll give us the grey angle there. That's going to be 180 minus 101, but also minus 41. So that is going to give us a 38 degrees. So 38 degrees is up here. And yeah, so we didn't end up needing the 11 in the end, because once I have that 38 degrees, the last circle theorem that's going to be involved is this one here, the V-kite, when you have the center. The angle at the center here in pink is twice the angle at the circumference. So basically we're going to double 38, and that will get our angle in pink. So 38 times by 2 will give us 76 degrees as our final answer.